In this video, I'm going to find the critical numbers for these two functions. Remember, the critical numbers are the numbers for which the function is defined and the first derivative is either 0 or undefined. So this first function, we're going to take our derivative, f prime of x equals negative 3x squared minus 6x plus 2. We're going to set it to 0 equals negative 3x squared minus 6x plus 2. This seems too hard to do by itself, so I'm going to use the quadratic formula. X equals negative b, which is 6, plus or minus square root of b squared minus 4ac, which is 36, minus 4 times negative 3 times 2, all divided by negative, so 2a, which is negative 2 times 3, which is going to give us negative 1 plus or minus the square root of, let's see, 36 plus 24. We've seen this before. That's 4 root 15, so that's root 15 over 3. So those are the critical numbers for this function. We'll do the second problem. Again, we do the same thing. We take the derivative. F prime of x equals e to the x minus e to the minus x. We set it to 0. 0 equals e to the x minus e to the minus x. And now we need to figure out when this is true. Let's factor out an e to the x. So that's going to be e to the x times 1 minus e to the negative 2x. Right? E to the x times e to the negative 2x is e to the minus x. That's how that works. E to the x is never 0, which means we have 1 minus e to the negative 2x equals 0. E to the negative 2x equals 1. And now we take the natural log of both sides, and we get negative 2x equals natural log of 1, which is 0, which means x equals 0. So the critical number for this function, e to the x plus e to the minus x, is x equals 0.